First, in winter, moist air from the house that gets into the attic is vented to the outside where it can't cause dry rot or other structural problems. And second, in summer, hot attic air is vented outside to help keep the home cooler. Always remember, if you can't ventilate, don't insulate. In this video, we'll look at how attic ventilation works, how to calculate the amount of attic ventilation needed, where attic vents are usually installed, and how to install various kinds of vents. Attics need both high and low vents to get good air circulation. Attic vents also need to be evenly spread out so that all areas of the attic are well ventilated. Warm, moist air in an attic rises naturally or is moved by wind out through the high vents. At the same time, cooler, drier outside air enters the attic through the low vents. This air circulation keeps the attic dry in winter and cooler in summer. Here are some different types of attic vents. This is a roof vent, sometimes called a roof jack. It's a high vent installed toward the top of the roof. It's not designed to be a low intake vent. This is a ridge vent. It's also a high vent. It's installed along the peak of the roof. This is a gable end vent. It's usually a high vent, installed in the gable ends of a roof. This is an eave vent. It's a low vent installed between rafters. This is a soffit vent. It's used as a low vent in homes where the rafter overhangs have been enclosed. This type of vent is sometimes used as a low gable end vent in story-and-a-half houses. These vents can be combined in different ways depending on the house. To ensure good ventilation, about half of the venting should be high and the other half low. Let's look at how vents are rated for airflow and how to calculate the amount of ventilation needed in an attic. Each of these vents has an opening to allow airflow. Since there must be an insect screen over the opening, some of the airflow capacity of the vent is reduced. The actual airflow rating is called the net free area. The term net free means the area in a vent without any obstructions. This is the number we need to know for each vent. The net free area is often printed on the vent or as part of the model number. This roof vent has 92 square inches of net free area. This soffit vent has 58 inches of net free area. To calculate the required net free ventilation area for an entire attic, first determine the area of the attic. Measure the width and the length. Multiply the width times the length to get the area. If the attic has several parts that all connect, calculate each part of the attic separately, then add the areas together for the total area. Include any area that is common to the main attic space, even if that area is over an unheated part of the house. For example, if the garage attic doesn't have a firewall separating it from the main attic, then you include the garage attic in your calculation. The rule for most ventilation is called the 1 to 150 rule. You divide the total attic area by 150 to get the net free ventilation area required. For example, if the total attic area is 1,500 square feet, you divide 1,500 by 150. The answer is 10 square feet of net free vent area. Sometimes the 1 to 150 rule provides more airflow than is necessary to achieve adequate attic ventilation. You can use the 1 to 300 rule instead if at least 3 feet of vertical distance separates the high and low vents and 50% to 60% of the vent area is installed as high vents. Or you can use the 1 to 300 rule if a vapor barrier is installed under the insulation next to the ceiling. This vapor barrier will be either plastic sheeting or foil or craft backing on batt-type insulation. If either of these 1 to 300 rule requirements can be met, divide 300 into the total attic area to determine the net free ventilation area you will need to install. Let's do an example. By holding a tape up from the eave, you can quickly see that there is more than a 3-foot vertical distance between the soffit, where we'll install the low vents, and the top part of the roof, where we'll install the roof vents. Also, there is room along the roof to place at least half the ventilation area high. Because these conditions exist, we can use the 1 to 300 ventilation rule to calculate the total vent area. The attic is measured and the total area is calculated to be 1,500 square feet. Divide 1,500 square feet by 300 to get 5 square feet of net-free vent area needed. Vents are rated in square inches. There are 144 square inches in a square foot. So we multiply 5 square feet times 144 to get 720 square inches. This is the total net-free vent area we will install. At least half of this net-free area needs to be high vents. Half of 720 is 360. The 92 number printed on these roof vents means each one has 92 square inches of net-free area. 4 roof vents gives us 368 square inches of net-free area, which meets the requirement that at least half the vent area be high. We locate the roof vents evenly spaced along the roof on the side away from the street so they won't change the appearance of the house from that side. Now for the low vents. The amount of vent area we need to install is 720 square inches minus the 368 square inches in high vents, or 352 square inches. These soffit vents each provide 40 square inches of net-free vent area. 9 vents times 40 equals 360 square inches. This gives enough net-free area to meet the low venting requirement and still leaves 50% of the ventilation in high vents. As seen here, we installed the vents evenly distributed along the soffit on all sides of the house so that air flows throughout the entire attic. Remember, we could have used other combinations of roof vents, gable vents, eave vents, or soffit vents to achieve the same result. No matter which combination of vents we use, it's very important to distribute the vents evenly so that all parts of the attic receive airflow.